Alright, so today we're going to look at lecture 4. Okay, so all of these have been taken out of the lecture slides. Okay, so first thing, what is, the chemical and physical properties of metals? So typically we can break it down into metals. Like for example, what are some good things that metals are good at? For example, metals are hard, right? So they are actually called malleable. Malleable basically means that they actually can be bent either from hitting them, or you actually can heat it up at very high temperatures and kind of bend it. Okay, it's kind of like those like people who make swords and so on, and metals are actually having high melting boiling point, and they also typically have a very good conductor of electricity as heat, as well as heat too. Now for the chemical properties, there's only really two things that you need to take note of. One is metals actually lose one electron to actually gain a positive charge, and they have a lower electronegativity. So if you don't know what a lower electronegativity means, don't worry, we're going to go through more into the later lectures talking about electronegativity between elements as well. So these are just some things that you need to take note for metals. Non-metals are typically brittle. So when we say brittle, they mean that it can be easily, broke or torn up. Okay, and they have a very low melting and boiling point, and they don't really conduct any electricity, nor good conductors of heat as well. But this time for non-metals, they actually gain the electron and form a negative charge, and they have a higher electronegativity. We're going to talk more about electronegativity in the future. And what is metalloids? So metalloids, you can just think of them as, semiconductors. So think of it as like between metals and non-metals. They may able to conduct electricity, but they also may not be able to conduct electricity. So it's kind of like between metals and non-metals. It's kind of a neutral partner there. Okay. And another one that I actually underlined red out here is actually called amorphoratic oxides. So amorphoratic oxides basically means that some of these elements that are amorphoratic oxides, right? They typically can react in a base as well as an acid too. So either one of those two. So looking at the classifications of elements through the periodic table, it's very easy to actually look at a periodic table once you have actually identified it. So these rows down here, right, are what I call the lead rows. And from the lead rows, right, they typically determine how many electrons there are from the periods itself. So now here, lead rows, and you can see how they actually split up into other metals. What this shows that those horizontal rows, like they have the same amount of electrons, same chemical and physical properties as well. So you're going to look at this slide, similar chemical properties, sorry, not same, similar chemical properties and physical properties as well. Okay, and they have the same number of valence electrons in the outer atomic structure. Okay, so I'm gonna skip this one because we did talk about alkane metals just now, so just same thing, just a bit identifying. Okay, now we're going to talk about halogens. So halogens are typically in group 7. Okay, so for example, you have fluorine, chlorine, bromine, iodine. The reason why halogens typically are so reactive is actually because they are missing one valence electrons. And when you're missing one valence electrons, right, you really don't want to, lose all those electrons. Therefore, you want to continuously gain one electron to actually stabilize the full outer shell of electrons. Therefore, most of the time they are very reactive as well. And next one is actually noble gases. So noble gases, they are typically have a full outer shell of valence electrons. They are actually very stable. Okay, so when I say they are stable, right, typically I refer to them as the octet rule. So the octet rule is basically where they are actually much more harder to react is because they don't really want to gain, lose, or even share any of these electrons because they're already stable. So why would they want to react with other elements? So it actually makes it much more harder to react with other elements itself. So you actually go and see down here. Yeah, talking about the periods. So periods just basically shows you how many valence electrons that they have in the outer shell. If you do know, the first shell down here, right, actually consists of 2 electrons, followed by the second shell, which has 8, and then from so on. I'm gonna skip this one, but this is actually supposed to be on lecture 3. So you actually can see this will be a mass number down here, and the atomic number down here. Like I said, if you want to find the number of neutrons, just take your mass number minus your atomic number, and you should get the amount of neutrons. So another thing I want to point out is that when we refer to your atomic structures of a element, you know how the first shell, right, actually has 2 electrons, followed by 8 electrons, and then it actually can go up to 18 electrons. But only elements like potassium as well as calcium can only fill up to 8 electrons down here in that third shell. Any of the rest of the elements can actually fill up all the way to 18. So for example, down here, we have magnesium. So you can see how magnesium, the first shell, we have 2 electrons, followed by the second shell, which has 8 electrons and 2 electrons on the third shell. The reason why is because we have 12 down here. So 2 down here, 8, and then 2 down here. So that leads you to 12. Let's skip this one. Yeah, so referring to the octet rule, like I said, typically I mentioned noble gases because they're the most stable electron arrangement. So they typically don't want to gain, lose, or share any electrons because they don't want to. Makes it much more harder to react with them. So you can see here on the octet rule, once the atoms achieve the octet configuration, it does not want to react easily with other elements to form new compounds. So it actually makes it much more harder to react with these elements, especially noble gases. So this is the last slide. So this is a very important slide you need to know. So we can see here, group 1, which is alkane metals, like for example potassium, your sodium, all these on that period. Typically they lose 1 electron. Followed by your alkane earth metals, they lose 2 electrons. And then your boron group, which loses 3 electrons. Your carbon group, which actually lose or gain 4 electrons. Followed by your nitrogen group, which gains 3 electrons. Your oxygen group, which gains 2. And then your halogens, which gain 1 electrons, followed by your noble gases, which are already stable, so they don't really have to gain or lose or share any of these electrons. And that's it for lecture 4.